Hi, coordinate geometry number 3, straight line, the MN formula number 2. If point C is a point on the line joining A and B and is external to AB and AC and BC ratio equal to M1 and M2 ratio, then coordinate of C, x coordinate is given by this one and y coordinate is given by this one. So let's try to prove this one. Here let's draw this simple diagram like this: x-axis, y-axis, and on the diagram we'll try to locate the points. So a is let's see here, a is equal to x1 comma y1, and b, let's take it here, b is equal to x2 comma y2, and AB is the line joining, and when you extend it you get C here, so C is an external point, in this case x3 comma y3. Now we know the x coordinate here will be the x coordinate at this point here, x1, and this coordinate, this is x coordinate of B, it is x2, and this is the x coordinate of C is x3, and similarly this is y1, y2, and y3, and it's given that AC and BC ratio is equal to M1 and M2 ratio. AC and BC ratio equal to M1 and M2 ratio. So AC is the total length from here to here, this is M1, and BC is from here to here, it is M2. So therefore the length from A to B can be taken as M1 minus M2. So this one is M1 minus M2, A to B. Now we have two similar triangles here. So A, B, and we'll take this point as N, and there's a rectangle here, and B, C, and let's take this one as R. So there are two triangles, ABN triangle, BCR triangle, ABN triangle, and BCR triangle, ABN triangle, and BCR triangle are similar triangles, similar triangles. Now we'll see the ratios of those sides of the triangles. AB over BC ratio, AB over BC ratio is actually given by M1 minus M2 divided by BC is equal to M2 is equal to AN divided by BR, AN, BR, similar side, BR is equal to BN, BN divided by CR, BN divided by CR. Now our task is to find out the lengths AN, BR, BN, and CR in terms of X, Y, and X1, Y1, and X2, Y2, and X3, Y3. So AN, straight away we can write equal to x2 minus, this is the origin, x2 minus x1, AN equal to x2 minus x1, and BR is equal to x3 minus x2, x3 minus x2, and bn is equal to y2 minus y1, y2 minus y1, and lastly CR is equal to y3 minus y2, y3 minus y2. Now we substitute all these values in equation 1 here. Then we get m1 minus m2 divided by m2 is equal to an equal to x2 minus x1, x2 minus x1 divide by br x3 minus x2, x3 minus x2 equal to bn y2 minus y1, y2 minus y1 divide by cr y3 minus y2, y3 minus y2. So we have two sets of equations here. Basically here one set and this one another set. What we need to do is to find out x3 and y3. Let's see how we can do it. So what we have for the first part, m1 minus m2 divided by m2 equal to x2 minus x1 divided by x3 minus x2. Now we take the cross product here, so that will give us m1 minus m2 times x3 minus x2 is equal to m2 times x2 minus x1. So now we expand these brackets. Here we can expand by multiplying m1 x3 times m1 x3 and m1 times x2 negative m1 times x2 and negative m2 times x3 negative m2 times x3 negative positive m2 times x2 equal to m2 x2 negative m2 times x1 2 times x1. So we can see this term here and this term here are equal. We can take that away, and now we need to find out value of x3 in terms of x1 and x2. So x3 is, we can take x3 out in this expression, x3 times m1 and here negative m2 equal to, we take this term to the other side, so that's negative m1 x2 become positive m1 x2 and negative m2 x1 here. Therefore x3 is equal to m1 x2 minus m2 x1 divided by m1 minus m2. That is the x coordinate of the point C. Similarly, we can get y3. For y3, just substitute the values of x with y. In this case, m1 x2 become y2 minus m2 x1 become y1 divided by m1 minus m2 is the answer. That is, therefore C is equal to x3 comma y3. Basically x3 is this term here and y3 is this term here. So these are the answers.